Just some old dude, really. Born in Samos, long time ago, 569 BC to 475 BC. He had a good innings, quite old. Who was he? He was a strange character. We don't know a lot, actually, because he didn't keep a lot of records. He led this kind of secret, half religious, half scientific society of people who kind of mixed religion with logical reasoning. Had to keep it secret because back in them days, science and logic was seen as defiance of God, and we all know how protective people get of their gods. So a lot of the time it was met with fear and sometimes violence, hence the secrecy. And it means we don't know a great deal. But we do know one thing that he noticed about right-angled triangles. So he noticed a thing about right-angled triangles that's quite special and handy. He said that if you create squares from each of the straight sides of the triangle, the space that they fill will always fit in the square created by the hypotenuse side of the triangle. Now the hypotenuse is the longest side. I tend to call it the slopey side to my students, and that seems to work quite well. But you'll note that in all the books it's called the hypotenuse. It's quite an alien term to use, and there's no wonder people get confused with all this stuff. But that's what he noticed. Sure, why not? Well, we simply write a squared plus b squared equals c squared. And the little 2 means that it's that letter multiplied by itself twice. And that's how you work out the area of a square. It's its length times its width. In the case of a square, that's the same value, isn't it? They're the same lengths each side. With these 3 equations. Now I've transposed this from what we wrote earlier, the a squared plus b squared equals c squared. And all I've done is cancelled out the square each time, moved one from one side of the equals to another. Look up the transposing video that I've done, because I actually cover Pythagoras in that. So let's just move to the whiteboard and I'll just go through each side and prove it with the classic 3, 4, 5 triangle. Okay, so here we have the triangle that we've been working to with our 3 labels A, B and C. And this is the equation that Pythagoras came up with based on his squares idea. So he said that the square created by this side plus the square created by that side, ouch by the way, will always add up. So the space those 2 take up will fit into the space that this side creates when you put it as a square. And written in maths, that's a squared plus b squared equals c squared. These are the 3 equations that we can create from this using transposition. And what I've done here, I've just created another right-angled triangle, and instead of using a, b and c, I've put in actual numbers. Now this is a classic 3, 4, 5 triangle, which any old builder will tell you about, and basically it's a really useful thing if you want to get a right angle. So if you measure 3 one way and 4 the other, then draw a line between, you end up with a right angle, and that's really handy for setting out foundations or door frames and things like that. Anyway, so we can write 3 equations for this triangle based on these. So if I just wanted to prove that this does actually equal 3, then we would use this equation because this is labelled A. So to put the numbers in, we've got our C value, which is 5, and it says to square that. And we need to minus the other squared number, which in this case is 4. So the square root of 5 squared minus 4 squared will equal 3. Let's prove that. So square root of 5 squared minus 4 squared equals 3. It does. So let's do the other side. Let's do our side B, which in this case is 4. So we're just going to prove that this equals 4 when we use this equation. So again, we start with our c squared, which is 5 squared. And this time we take away this portion, so 3 squared. And that should equal 4. So let's try that. Square root of 5 squared minus 3 squared. And it does, it equals 4. Wouldn't you know it? And then the last side, the hypotenuse. The equation's a little bit different. On the other two, you can see we start with the hypotenuse and take away the other one to reveal the side we're interested in. This time we're adding the 2 up, which is similar to the original equation, but instead here we've just cancelled out that square by putting in a square root. So we want to prove that to get 5 we have to do a squared plus b squared, which in this case is 3 squared plus 4 squared. So let's try that. Square root of 3 squared plus 4 squared, it gives us 5. Happy days. So that's Pythagoras' theory. And you know, we've been talking about, you know, just numbers, but these can represent quite a lot of things, and Pythagoras tool, if you like, is used quite a lot in engineering. In electrical, we use it to calculate our impedance, so resistance squared plus reactance squared, all square rooted, gives us our impedance. And that's because they, reactance and resistance act in 90 degrees away from each other. You can use this if you're planning a route and you want to know the shortest distance. If you know the lengths of, say, a field maybe, and you want to cut across or maybe dig a trench through a field. If you know these lengths already, it's quite easy to know how much ducting you need or whatever. We use them in our power triangles in electrical. We use it quite a lot, even lighting actually. So, you know, it's not just some dumb thing your maths teacher makes you learn. If you're going to be an engineer or a scientist, then you definitely need to know it. And there we go. Pythagoras, done. See ya.